Hi, my name is Kepsi Richard. Welcome to my YouTube channel. Please, do you have a problem in partial differentiation? If the answer to this question is yes, then this video is meant for you. Quickly subscribe to the YouTube channel, like and comment. This will make my YouTube channel grow more and I can record more mathematical content for you. So today, our discussion strictly will be on partial differentiation. So, partial differentiation is done if a function is dependent on two or more variables. So, when a function is dependent on two or more variables, and partial differentiation is performed with respect to one variable, the other variable or variables will be held constant. So, for instance, if we have a function f that is dependent on x, y, and z, and we are performing partial differentiation of this function with respect to x, then y and z will be held constant. So please take notice. So this is how we write it. The partial differentiation of the function with respect to x. That's f subscript x. Then, let's say the function is dependent on two variables only. This is the same as del f over del x. So please take note. If you do not see this, it's the same as that. Also, the partial differentiation of the function with respect to y, in that case, the x will be held constant. So in that case, this is the same as del f over del y. Also, we can perform partial differentiation of the function with respect to x, then with respect to x again. In that case, we differentiate the partial differentiation with respect to x, with respect to x again, and the y will be held constant in that case. And this is the same as del square f over del x square. Please take note anytime you see this. In this discussion, we'll be using only the f subscript xs. But if you see the del square f over del x square somewhere, they are the same. They are just asking you to perform partial differentiation of the function with respect to x twice. So that's it. Also, we can have partial differentiation of the function with respect to y twice. In that case, we'll do the second derivative with respect to y for the function f subscript y. Very, very important. And this is the same as del square f over del y square. Also, they can ask us to perform partial differentiation of a function with respect to x, then with respect to y. In that case, we will do the partial differentiation of the function with the function which we with respect to x, that's this function, now with respect to y. I hope you get that. So this is the same as del square f over del x del y. Anytime you see it, they are the same. Also, we can ask to perform partial differentiation of the function with respect to x, then with respect to y. With respect to y, then with respect to x. In that case, we'll perform partial differentiation for this function now with respect to x. And this is the same as del square f over del y del x. I hope you get that. Now we'll take some sample questions and I will take you through practical ways of performing partial differentiations. So let's solve our first example. They say given that a function f dependent on x and y equal to 2x cubed plus 3xy squared, we should find the partial differentiation of the function with respect to x. We should find the partial differentiation of the function with respect to y. Partial differentiation of the function with respect to x, then with respect to x again. Then partial differentiation of the function with respect to y, then with respect to y again. Then v, the partial differentiation of the function with respect to x, then with respect to y. Then vi, the partial differentiation of the function with respect to y, then with respect to x. So how do we do that? Remember, our function f of xy is equal to 2x cubed plus 3xy squared. So remember, we said if you are performing a partial differentiation of a function with respect to x, then y will be held constant. So this will give us 6x squared. Then it's with respect to x, so this is linear. So we have 3y squared. The second one, we want to perform partial differentiation of the function remember the function xy is equal to 2x cubed plus 3xy squared. Now we'll perform partial differentiation of the function with respect to y. So what happens? The x will be held constant. So the whole of this will be 0. Then this, when we differentiate this function, we'll get 6 x constant and y. I hope you get that. The third one, we are going to do the partial differentiation of the function now with respect to x twice. So first, what is the partial differentiation of the function with respect to x? It's giving us 6x squared plus 3y squared. That's this one. Now the partial differentiation of the function with respect to x again will be equal to, this will give us 12x. Since there is no x component there, the whole of that will be 0. So solve the fourth one. That's the partial differentiation of the function with respect to y, then with respect to y again. In that case, we need to find the partial differentiation of the function with respect to y. And what do we have? Look at it. We have 6xy. So that's 6xy. Now the partial differentiation of this function with respect to y again is what we are finding. So in that case, the x will be held constant. So we have 6x. I hope you get that. Now the v. You say we should perform partial differentiation of the function with respect to x, then with respect to y. So what's the partial differentiation of the function with respect to x? Is 6x squared plus 3y squared. The partial differentiation of the function with respect to x is 6x squared plus 3y squared. Then the partial differentiation of the function with respect to x with respect to y means that we should differentiate this function now with respect to y. So x will be held constant. The whole of this will be 0. Since there is no y component, then this will give us 6y. I hope you get that. Then the vi. That's the partial differentiation of the function with respect to y and then with respect to x. We have to locate the partial differentiation of the function with respect to y. And if we have not done it, we need to do it. But we have done it in this case. That's 6xy. So we said the partial differentiation of the function with respect to y is 6xy. Now the partial differentiation of the function with respect to y, then with respect to x. That means we should differentiate this function now with respect to x while we held constant. So what do we get? We get 6y. Look at it. You see that the partial differentiation of the function with respect to x, then with respect to y, is equal to the partial differentiation of the function with respect to y, then with respect to x. So this is actually Young's theory. Young's theory says that when a function is a continuous function, the partial differentiation of the function with respect to x, then with respect to y, will be equal to the partial differentiation of the function with respect to y, then with respect to x. In this case, and both of them are equal to 6y. I hope you get that. We'll solve one more example on this. So example 2 says that if a function f depending on xy equal to sine 2x plus cos y, we should find the partial differentiation of the function with respect to x as the partial differentiation of the function with respect to y, the partial differentiation of the function with respect to x, then with respect to x, then iv, the partial differentiation of the function with respect to y, then with respect to y, then v, the partial differentiation of the function with respect to x, then with respect to y, then vi, the partial differentiation of the function with respect to y, then with respect to x. So how do we solve this? Remember our function f of xy is giving us sine 2x plus cos y. So when we are performing a partial differentiation of the function with respect to x, y will be held constant, and vice versa. So the first one, the partial differentiation of this function with respect to x, y will be held constant. So any place there is y is constant. So when we differentiate this, remember how to differentiate this. We differentiate this used to multiply the differential of that. So we get 2 cos 2x. Since this is constant, it becomes 0. Then the second one, we perform partial differentiation of the function with respect to y. In this case, x will be held constant. So this will be constant. When we differentiate cos y, we get negative sine y. The third one, the partial differentiation of the function with respect to x, then with respect to x. That means that we perform partial differentiation on this function again with respect to x. In that case, if there is any y variable, it will be held constant. But in this case, there is no y variable. So we can say this is negative, since the differential of cos is negative sine, we say negative 4 sine 2x. I hope you get that. The IV, the partial differentiation of the function with respect to y twice. So what do? We perform the partial differentiation of this function. That was the partial differentiation of the function with respect to y. With respect to y again. So in this case, x will be held constant. And there is no x component there. On differentiate sine y, we get cos y. So that will be negative cos y. So now we want to perform partial differentiation of the function with respect to x, then with respect to y. What do? We need to find partial differentiation of the function with respect to x first. Y will be held constant. We have already done that. Look at it. That's 2 cos 2x. So we say this will be 2 cos 2x. Then we perform partial differentiation of that with respect to y now. X will be held constant. So the whole of that, since there is no y, is constant. That will be 0. And the vi, we want to find partial differentiation of the function with respect to y, then with respect to x. That means we perform partial differentiation of the function with respect to y, then we find with respect to x now. So partial differentiation of the function with respect to y. Look at it, we solve that and have negative sine y. So we have negative sine y. So now partial differentiation of the function with respect to y, then with respect to x. What would that be? That means we perform partial differentiation on this function with respect to x, y will be held constant. Since there is no x component there, the whole of that is constant, that will be 0. And look at that. It's true that the partial differentiation of the function with respect to x, then with respect to y, is equal to the partial differentiation of the function with respect to y, then with respect to x. All equal to 0. I hope you get that. We'll solve our last example on this so that you'll be abreast with the point. So please remember to subscribe to my YouTube channel before you sign out. Now pause the video and try solving. After that, you compare your answers with mine. Now compare your answers. They say given that a function f dependent on two variables x, y is equal to sy cubed plus x squared y squared, we should evaluate or find the value of partial differentiation of the function with respect to x, then with respect to x at the point 1, 2. And the partial differentiation of the function with respect to x, then with respect to y at the point 2, 1. So how do we do that? Remember our function f is equal to xy cubed plus x squared y squared. So we want to find a partial differentiation with respect to x twice. We have to find with respect to x first of xy. So the y will be held constant. So this will be y cubed. Then this will be 2xy squared. I hope you know this by now. So now we'll perform a partial differentiation with respect to x again. Y again will be held constant. So the whole of this will be 0. Then this will give us 2y squared. So at the point 1, 2, that means any place we see x, we substitute 1. Any place we see y, we substitute 2. So since there is no x here, we have 2 squared, y is 2. 2 squared is 4. 2 times 4, that will be 8. Now the second one, the partial differentiation of the function with respect to y, then with respect to x, then with respect to y at the point 2, 1. So first, we need to perform partial differentiation of the function with respect to x. In that case, the y will be held constant. So what we have here, we have y cubed, then plus 2xy squared. Then now we perform partial differentiation of the function with respect to y. So the x now will be held constant. So this will give us 3y squared, then plus 4xy. So at the point 2, 1, that will be 3 times. So x is 2, y is 1. 3 times 1 square plus 4 times 2 times 1. 1 square is 1 times 3 will be 3 plus 4 times 2. Okay, so then 4 times 2 is 8. 4 times 2 times 1. 3 plus 8, that will be 11. I hope you get that. So we'll end it here today. Please remember to subscribe to my YouTube channel before we sign out. My name is Differentiation.